Okay, so I think that's recording. There we go. So so I factored the top part there, and then we're going to go about factoring the bottom. Since it doesn't factor by grouping, you'll have to use your long division or synthetic division skills to do that. Rational roots theorem, right? You got plus or minus 1, plus or minus 2, all of that stuff, right? 6, 5, 5, 6, and 10. Oh, I forgot 3. Plus or minus 3, plus or minus 6, right? All the things that go into 30 should be something smaller than that, so I'm going to just go with those. But there is the 10, the 15, all that good stuff. So, right, synthetic division, so you're going to use one of those. I'm just going to go with positives here because it looks like it'll probably come out to be a positive number just based on those, but we'll see. All right, so if I go 1, negative 4, negative 11, positive 30. All right, so drop the first one down, multiply, obviously not going to get me to 30, right? But we're getting pretty close. It's kind of in the right direction, so I'll try the 2. 1, negative 4, negative 11, 30. So drop the 1. Negative 2 makes negative 4. That makes negative 15, and that one works, right? Negative 30 creates 0. So that means that it factors. So then I know that one of my factors here is x minus 2. Remember, you do have to switch it back because if we do in synthetic division, I would have to change it to make it positive 2 over there. So then I've got x squared minus 2x minus 15 left, right, which just factors to x minus 5x plus 3. Gives me negative 2, so x minus 5, x plus 3. All right, so once you get it all factored out, things that you're looking for, number 1 is does anything cancel, right? So obviously I have one that cancels here, which means that I have a whole at x equals 2. All right, if you want to know where the y value of the whole is, so if you need the coordinate so you can graph it, okay, then you plug that into the rest of the equation. So without the discontinuity in there, plug it into the rest. So that would give me 6 over 2 minus 5 is negative 3. 2 plus 3 makes 5. So that gives me negative 6/15. Ugly, but it's okay. All right, so there's a whole. Okay, and then the bottom part makes vertical asymptotes. So x equals 5 and x equals negative 3. Okay, the top part makes our roots or our x-intercepts, zeros, they're all the same thing, right? So my x-intercept would be at negative 4, 0. Right, y-intercept, just plug a 0 in for x. Again, forget about the discontinuity so you can remove it. All right, so plug in the 0 there. That would give me 4 over negative 5 times 3. Right, so 4 over negative 15. Right, so just plugging in a 0 for the x value there. All right, so you get 4 on top, and you get negative 5 times 3 on the bottom. So negative 4/15. So x is 0, y is negative 4/15. All right, and then, all right, so holes, vertical asymptotes, x-intercepts, y-intercepts, we need our horizontal asymptote. That's where you have to go to those rules. When the degree on bottom is bigger than the degree on top, then it's automatically y equals 0. Okay, automatically y equals 0. And we can cross horizontal asymptotes. We're going to here because we have an x-intercept on the asymptote. So you're going to cross. All right, so then if I want to graph this thing, you take all this information and you throw it on a graph. So here's my graph. Right, I've got a vertical asymptote at 5. Draw vertical asymptote, dotted line. Got one at negative 3. Vertical asymptote. Okay, horizontal asymptote on the axis. If you have to do that, please make sure that I can tell where your horizontal asymptote is. And then I've got the whole at 2, negative 16. So 1, 2, negative 6/15. All right, which is just down here-ish. There's a hole. All right, I've got a y-intercept at 0, negative 4/15. So that's just a little bit above where the other one was. Okay, so you can kind of see what shape that's already starting to make. X-intercept at -4. Right? So we've got all of this stuff graphed, right? All of our pieces. So then it comes a matter of plugging in points to figure out where you need to be, because we need to know if we're above or if we're below. Here, right, this one, these values are already below, and we don't have any x-intercepts from here to here, which means that it's not going to cross the x-axis and go to the top, because if it was, there would be x-intercepts, and we don't have any. So this one is obviously going to go towards these two asymptotes like such, go through the y-intercept, go through the hole, but without actually touching the hole there, and then towards your asymptotes. All right, we can't turn upward, because if we turn upward, we're going to cross the x-axis, and we don't have any zeros there. So if there are no zeros that exist there, then you can't just cross the x-axis, right? And then here we need to know whether we're going to be on top or on bottom, right? We're obviously going to have to cross through that asymptote. So we're going to have to figure out whether it's on top or on bottom. So just pick another value. So this is -4. So we'll come out here to -5 to figure out whether we're on top or on bottom there. So when you plug in -5, right, going up here, so -1 on top, and then on bottom would be -10 times -2. All right, so -1/20th. All right, so that's just plugging into this equation without the continuity. All right, so since it's negative, all right, that means I'm going to be below the axis, so I'm going to be right here somewhere. I have to cross through this x-intercept, so I know this thing is going to go through the x-intercept and up on this side. And on this side, it's going to do that weird loop back and then just come up here. It has to get close to that intercept as we go out towards -infinity, because the bottom is getting bigger faster than the top. So we know it gets close to the 0 as we go to -infinity. So it's just going to come from the bottom instead of the top. And then on the other side, you do the same thing. All right, so this is at 5, so pick 6, plug that in. All right, so 6 plus 4 on top would give me 10. And then 6 minus 5 is 1. And then 6 plus 3 makes 9. So we get 10/9. So just over 1 on this side. All right, so since it's on that side, then we're going to come through and hit this one from this side. Okay, and we don't have to worry about whether it crosses over here, because if it did, it would have an x-intercept over here. All right, so we don't have to worry about whether it crosses, because if it did, it would have an x-intercept. So that's what that graph would look like. All right, so that's if the denominator on bottom, the degree on bottom is bigger than on top, you've got that horizontal asymptote at 0. All right, so everything else, the pieces are all the same. The thing that's going to change is your horizontal asymptote. So the next one I'll show you looks like such. -5x. All right, so something like that. Again, factor first. All right, x plus 1, x plus 1. All right, so get it all factored out, and then find all the pieces that you can. Nothing cancels, so there are no holes. I have an x-intercept at 0 and 1 at -5. All right, that's because the top makes my x-intercepts. I've got vertical asymptotes at -1. X equals -1. All right, because of the bottom. It's the same one twice, so it doesn't really matter, right? So there's your vertical asymptote, horizontal asymptote. So the degree of the top and the bottom are the same. So you find the coefficients and divide them. So it's just -1 over 1, which is just -1, right? Just dividing those leading coefficients. So there's your horizontal asymptote. I can get my y-intercept, plugging in 0. All right, when you plug in 0, you would get 0 on top, right, over 1. We should already know our y-intercept, just kidding, because it's right there. All right, but if I do that, I get 0 on top and 1 on bottom, so 0 over anything is just 0. So going through the origin. And then right? We don't have any holes. So that's really it. So then graphing. Okay, same sort of thing. So I've got an x-intercept at 0, 0, right? I've got negative 5, 0. We know they're crossing at those 2 points. I don't have any holes. I've got a vertical asymptote at negative 1. Okay, and I've got a horizontal asymptote at negative 1. Okay, and then y-intercept is already there at 0, 0. So the only other thing we need to know is whether or not this thing is going to cross our asymptote, right? So we need to know if it's going to cross our horizontal asymptote. So I take my equation, set it equal to it to see if it's ever going to touch it, right? So negative x plus 5 over x plus 1, I'm just going to write squared. Set that equal to negative 1. Okay, so when I multiply that over, I'm going to go ahead and go back to the factored form because it'll make it easier. 5x, right? Because I'm going to multiply this x plus 1 squared over. Okay, I'm going to go ahead and rewrite these things in their original form just because it'll make my life easier, right? So negative x squared minus 5x on this side, and that's equal to negative 1 times x squared plus 2x plus 1 when you distribute that back out. So negative x squared minus 5x equals negative x squared minus 2x minus 1. Okay, simplify all of that stuff down and solve for x. Those cancel, right? Add your 2x. Negative 3x equals negative 1, so x equals positive 1/3. Right, so at x equals 1/3, it is going to cross. So if this is 1, this is 1/3. So we are going to have this thing cross on this one right there at 1/3. All right, and you already have points, so you can already see what this thing is going to do. So it's going to come from up here, go down through the origin, back through the asymptote. It does have to go back to the asymptote, so we just come back from the bottom. Same thing here. It has to go through this point, so it'll get close to that asymptote, cross through that x-intercept, go to the other asymptote. Right, and every asymptote is going to eventually get to infinity. It's going to get close to those asymptotes. You just have to figure out whether it's on top or bottom. And for these, it's, you know, is it going up or down? All right. So then one more type, which has the piece of paper. Right. So one more that's got the slant asymptotes to them. Okay. So if I have something like x squared plus 4x plus 3. That's a 3 over x plus 2. Right, if I'm looking at this, the degree on top is bigger than the degree on bottom, which tells me there is not a horizontal asymptote, but there will be a slant asymptote. Okay, as long as you have a variable left on the bottom after you cancel discontinuities. Oh, I guess I should check that first. Sorry, I already know that it doesn't, but right, check for discontinuities first. All right, nothing cancels, because if everything cancels, you end up with a line. Right, but if we don't cancel the denominator, then there has to be either a horizontal or a slant asymptote. There has to be. Okay?
So you're saying if there's holes, there won't be a slant asymptote?
I am not saying that. I'm saying if your entire denominator cancels, then there won't be. All right, because you can have a hole, like the first one, we had a hole, but it still had stuff on the bottom. Right? But if everything on the bottom goes away, it's just going to be some kind of line or quadratic or whatever. All right, so then slant asymptotes. Right, to get those, you divide the bottom into the top. All right, that's how you would end up with that. So x plus 2 into x squared plus 4x plus 3. Yes, you can use synthetic if you prefer. Doesn't really matter. All right, multiply by x to get x squared plus 2x. Change both signs. Don't forget that part. 2x plus 3. Right, so to get x, to get a 2x, you would need a 2. 2x plus 4, change both signs, negative 1. Right, we don't really care about the remainder there. This technically would be minus 1 over x plus 2 as the remainder, but this part's going to converge to 0, so all we really care about is the x plus 2. So y equals x plus 2 is how the slant asymptote will look. This right here just tells me how quickly I get to that asymptote. Right, so slant asymptotes, horizontal asymptotes, we got to finish all of our stuff, so we need a vertical asymptote. Right, so vertical asymptote is at x equals negative 2. Right, we need an x-intercept. Those come from the top zeros, so x-intercepts happen at negative 3 and negative 1. y-intercept, plug a 0 in for x. All right, when you do that, you would get 3 times 1 over 2. All right, so 3/2. I think that's it, right? So we don't have any holes, nothing canceled. All right, so then graphing, So then graphing there. Put all your pieces on there. So the vertical asymptote happens at -2. Okay, and then my slant asymptote happens at 2 with a slope of 1. Alright, so same sort of thing. That's just graphing a line, right? Y-intercept of 2, slope of 1. Super important to remember that the asymptotes aren't actually part of our graph at all. They're just guiding points. Alright, so they don't show up when you graph on Desmos because they're not actually part of the graph at all. They just guide our graph. Anyways, so there's that. We've got our x-intercepts at -3 and -1, and a y-intercept at 1 or 3/2, 1 and 1/2. All right, so just by looking at that, you can kind of tell the direction that it's supposed to go. So it has to cross through here, which means that it has to go to this side, all right, and this side. And then it does have to go from this side to this side. Technically, you should set the 2 equal to see if it's ever going to cross because it can cross a slant asymptote as well. But you can set it equal and test that to see if it is actually going to cross just by setting it equal to the x plus 2.
I have a question.
Yes.
So those are those, but how would you find like opposites? So if they give you the graph form, you have to find opposites.
So once you know where the parts come from, you just put them back where they came out of. So for instance, here, right, you know vertical asymptotes come from the denominator. So if I have a vertical asymptote at -1, right, x equals -1, well then move it back into a factor and put it back on the bottom. Vertical asymptote, x equals 2, right, move it back to a factor, so I subtract it over, put it back in the denominator because that's where vertical asymptotes come from. Right, zeros come from the top, so I have 1 at 0, so I have to have an x there. And I have 1 at 3, change it back to a factor, so x minus 3 had to be on the top. Okay, this one has a horizontal asymptote at 1. It's horizontal and it's not at 0, which means it has to have the same degree top and bottom, and the ratio has to equal 1. So when you look here, I've got an x squared and an x squared. 1 divided by 1 would make 1. That's it.
And none of them like hit at 0. Like if there's no like x is on 0, like in a different equation, like in a different graph.
Like this. So if there are none, then that means that the top does not have.
Oh, just be 1.
So, or you can have holes, but like this one doesn't have any holes in the graph, right? So it's just a number up top, right? Because there's no variable up there.
So that's if you don't have any asymptotes, or that's if you don't have any horizontal.
Any roots.
Oh, roots.
Any roots. This has a horizontal asymptote at 0. But I don't have any roots. It never crosses the x-axis.
This might be a stupid question, but how do we know what number is on top if there aren't any?
So you can put an A here, pick a point off of your graph, and then plug it in for x and y and solve for A.
Okay.
And this was just a guesstimate because it said pick possibles, so that's just a guesstimate because they don't give you really good points to test.
The